The topic of this video lesson is going to be surface areas of cylinders, as you can see, and specifically we're going to look at drawing the net first of a cylinder, and then after we're done with that, we're going to calculate the surface area of the cylinder. But before we get going, we first have to learn a little vocab. Our first vocab on this one is going to be a net drawing, a lot of times just referred to as a net. And all that is doing is it's essentially taking a three-dimensional figure and flattening it out into a two-dimensional figure. So being this lesson is about cylinders, I have a really good GeoGebra app here to help us look at what the net of a cylinder will look like. So there's our cylinder. Now what happens is, like I said, we need to take this and flatten it, and it doesn't mean just step on it and smash it. We want to pull it apart and look at all of those surfaces that make up that two-dimensional or that three-dimensional shape. So as you can see, this is going to pull it apart. We see a cylinder up there coming off, and then this is the part that I want us to focus on. Notice this round cylinder part of it. Notice it's flattening out to become a rectangle. And I'm going to flatten it all the way down. The other piece that I want us to notice is the circles. I'll call it the outer ring and the circle. Those are going to come off now, and now notice where that part goes. It becomes the length or the base of the rectangle. So what goes around the circle, which we'll refer to as the circumference, actually becomes the length or the base of our rectangle. Now I want to go back. If the circumference is the length or the base of the rectangle, what's the height of the rectangle? So I want you to watch where that height is when it goes back into the cylinder. Keep watching it. So that height actually becomes the height of the cylinder. There's our net laid out flat. Notice it's two circles, which I think is pretty easy to see. We see those in the cylinder, but that rectangle, that's kind of the new piece that I think of. So I'm going to bring us back. So I want us to draw a net of a cylinder. Now, I'm not going to get real picky that it's perfect and drawn to scale, but we'll just remember that we had a rectangle, and there was a circle here, and that one had a circle here. Those should be the same size. But here's the thing. Those circles, the one we saw on the previous page, were right in the center. They don't have to be. Those circles can be anywhere. Here, there. It doesn't matter where you put them along that part of the rectangle. Now, they can't be on this part because that's the height of our cylinder, and the circles don't attach there. They attach to the length of our rectangle, or the base of our rectangle. Now, some things that are not cylinders, as far as a net would go, you could draw the rectangle, put that circle here, and the circle here, it kind of looks like a wagon. That's not going to work, because if we try to fold that up, these two circles would end up on the bottom, and there wouldn't be a circle on the top to cover that up. Some other things that don't work, if you tried to put that circle out here and here, that won't work. Now, nets come in a lot of different, or nets of cylinders come in a lot of different shapes and sizes. So sometimes you may have a net that it could look like this. This would be a tall, skinny net. Now, this circle here would have to be really small, and this one would be really small. But that would work as a net as well. Now, let's go on. The other part of our lesson talked about surface area, and that's this second vocab word that we have here. That's the sum of the areas of all those faces. So if we look at the area of each piece, I like to think of that we can touch and add all those together. That's going to give us our surface area. So I come back to the cylinder, since that's our topic of today, and I look at it and I go, I need to find the surface area of this net. I've just taken the cylinder, I pulled it apart, I have my two circles and my rectangle. Now, I'm gonna give you the formula. I'm not a huge formula person because I forget them frequently. Now, there are some formulas that we just have to remember, but I don't like to cram your brains with lots of them. But this is the surface area formula of a cylinder. Now, it says 2B. What does the B stand for? Well, the B is the area of the bases, and those bases, remember, in a cylinder are the circles. Well, I think back and go, we know how to find the area of a circle, so I could take that green B that's in the little formula there, and I could replace it with the area of a circle. So it becomes pi times your radius squared. Now you still have that 2 out front, like that. So think of it as this part right here just became all of that. Now the second part, the P times H. P is the perimeter, and I will tell you that I have a little typo here, and I'm going to fix that. This should be a capital P. The perimeter is usually capitalized. But perimeter, now this doesn't really have perimeter because we're dealing with a circle, so it's really the circumference. So think of it as the circumference of your circle, and remember the circumference of that circle was right here. Remember, this is the part that wraps around our circle. So I think back and I go, well, how do I calculate circumference? Well, circumference, remember, was 2, well, I'm going to keep it purple for right now. Circumference is 2 times pi times the radius. And then that h, well, that's still the height of our cylinder, which is also the height of that little rectangle. So when I look at, if I really wanted a surface area formula, this is the one that I would use. But again, I try to think of it as surface area is the area of all those parts. Well, there's 2 circles, which is this first part, and then there's that rectangle right here. So if we can find the area of those pieces, add them all together, we'll have our surface area. So I have a little example here. Calculate the surface area of this cylinder. So I'm going to think of it as surface area equals 2 circles plus the rectangle, thinking back to your net. So the area of a circle is 2 times pi times the radius. Well, I come over here and notice that my radius is 9 yards because that's going to that little piece there. So I'm going to put in 9 for radius, and then remember we have to square it. Because this much, and you don't have to put this in parentheses, but that much right there, that's the area of 1 circle. And since we have 2, I'll put the 2 in front of it. Now we still have to add on the area of that rectangle, remember, that wraps all the way around. Well, the base, remember, of the rectangle is the circumference of the circle. So we got to find the circumference of the circle. And to do that, we're going to do 2 times pi times the radius, which is 5. So there's the base of the rectangle right here. Now we need to multiply by the height of the rectangle, which is the same thing as the height of the cylinder. We probably don't put an h there. Let's put a 5 there because that's the height. And there we go. Now it's just a matter of multiplying this all together and calculating what it equals. So I'm going to look at this and I'm going to go, well, this is still 2 times pi, and then this is 9 squared is 81. Plus, I'm going to multiply my 2, my 5, and my 5 together. That will put us at 50 pi. So this is 162 pi plus 50 pi. And then when we add those two together, we end up with 252 pi. And now label would be yards squared because we're looking for how many little squares fit inside of it. This is the exact answer. Now, if I wanted the approximate answer, now this is where I'm going to go to my calculator. So I pull up my calculator. I'm just going to type in 252 times pi and push enter. And I notice it comes out to be 791.6813487. Now, most of the time, the problem would tell us what to round to. I'm going to round to the nearest hundredths in this case. So I look at the 8, 1's next, leave it at 8. So final answer is going to be 791.68. So I'm going to go like this. The approximate 791.68 is what we said, right? Yes. And then I'll put my label on that. Yards squared. Probably put my little s in here too. So we found the area, the exact area is right here, and the approximate area is this one. All right, one more. Calculate the surface area of this one. This one's a little different. I tilted it. That's the only difference. So I'm going to look at this. Surface area equals, and I'll put the formula that you saw earlier, 2b plus And I drew my P little again. I should draw it big. Perimeter times height. But again, remember, 2 circles, 1 rectangle. So 2 circles, pi times the radius in this case, that's 5 this time. So 5 squared plus now the perimeter or the circumference technically of our circle. So to calculate the circumference of that circle, we're going to do 2 times pi times the radius, which is 5. There's the base of the rectangle that we would have if we had the net drawn, and then times the height, which is 15. And then again, it's just a matter of simplifying all this. So now we have 2 times 5 squared is 25, so 25 pi. Plus, I'm going to multiply 2 times 5 is 10, and 10 times 15 is 150. So I have 150 pi. This is 50 pi plus 150 pi. And we end up with a final answer, an exact answer of 200 pi inches squared. And now let's also look at the approximate. So we'll come back to our calculator. And now we put in 200. And on this calculator, I don't even have to push the times button. I can just push times. It will know to multiply that. And we end up with 628.318. Again, I'm going to go to 2 decimal places to the nearest hundredth. So I look at the 1. The 8 is after it, so I'm going to have to bump that 1 up to a 2. So my approximate answer is going to end up being 628.32 inches squared. So I now have my exact surface area and my approximate surface area of that cylinder. And that's going to conclude our lesson on surface area of cylinders.